When we started with multiple nodes, we identified a mechanism in which we chose node 3 as the destination and node 0 as the source. Then we also looked at a way to randomize it by choosing a random destination every time a node receives a message. Here in this particular module, we are going to look at the message itself. Usually, the message that we considered here did not contain any information at all. But if we want that message to carry some information, like an IP packet carries source IP address, destination IP address, the TTL field, the hop count, and payload, we are going to need the definition of a message from a message class. So as I said, instead of hard coding, we need flexibility, and we need to draw out a random destination that we did so far, but we need to also show that in a packet, when the packet is moving from a source to a new randomly chosen destination, and it also has to carry the source address. For that particular understanding, please refer to ticktalk13.ned, txe13.cc, and a new file that is ticktalk13.message. If you recall, when we had started getting an introduction to Omnet++, there we looked at a flowchart in which the message files and the header files were becoming part of the compiling and linking process. But we had not touched it, and we had said that we are going to discuss it in detail subsequently. Now it is the time to explore it further. In order to make an effective strategy to create a message that carries the information that we want it to carry, instead of rewriting it from the scratch, we are going to benefit from the CMessage class, and we are going to inherit or extend the TickTalk message from there. So ticktalk13.message that you are going to find online subclasses the CMessage and adds destination, source as data members. It is important to mention here that with the usage of this subclassing, we are avoiding a very cumbersome boilerplate code writing, where we actually have to replicate the code at so many places in NED file, C++ file, and so forth. And these changes are so trivial that it becomes monotonous and at times devastating. So now we are going to look at how this linking works. When we create a file, ticktalk13.message, that contains nothing but declaration of the source and destination as integer variables, that particular message file generates the header file, ticktalk13_m, the header file. This header file must be included in ticktalk13_m C++ file, because if it is not included, then when we run and compile the program, it is not going to find the header file, because whatever ticktalk13.message created is not included in the C++ file. So be sure to do that. So after compiling and linking, we are going to get a class called ticktalkMessage13 class. This class will have all the mutator, that is the getter and setter functions, available for every field. So whichever field the arguments such as the source address, the destination address, and the payload, the TTL, whichever we want to call, would be used with ease. Now, when we look at the C++ code, txe13.cc, here we can skip most of the other stuff and concentrate on wherever the arrows have been marked. Here we see that the destination is chosen again through a uniform distribution process, and here we see that the range is from 0 to n-2, such that the node itself is kept out of it. Similarly, we see that here the message, as we see in the sprintf command, carries the addressing information as tick -%d to -%d, where the first one is the source address, that is the source ID, and the second one is the destination ID. And as we saw in earlier modules, that using the sequence ++ operator, we are incrementing the sequence number every time. Here we see that when the handle method is called, here we see that if the TikTok message reaches at the destination, whereby the index which is called for that particular node and the destination match, the message arrived display is done. And when the node receives a message, it has to send out the message once again. So you see that in this command, in this line of code, TikTok message 13 star new messages generate message, the destination now becomes the source. Now, if the destination has not been reached, it means that this is not the destination, so the node must relay it, must forward it. So it uses the forward message. When we look at the forward message, we see here that here the hop count is incremented, again using uniform random distribution. The destination is chosen and the message is forwarded. The forward message is also displayed onto the screen. We see something interesting here, that the send method has the first argument as the message itself. The second argument actually shows that we are using the out gate of the gate that we defined, because the gate that we define now has both input and output options for it. Now we are using the output option of it. Finally, when we look at this code in the TK environment, we see that whenever a node receives a message, it sends out the message, and on arrival of the message, it also shows a bubble, that is, the message has arrived and it is going to start sending a new message.